Dope. Okay, we're recording, and I hope that this mic isn't the worst in the world, but it's going to be not great. Sorry for any of you, those who listen to this recorded message once Mike gets his hands on it. We don't have Logan's mic or anything, so it's my laptop's in webcam mic and the sound system, so sorry guys. Genetic algorithm document got released. I hope all of you have read it at this point. Yeah? Who here's read it? Okay, I don't see all hands. Oh. Okay. Have you read Genetic Algorithms document? Okay, so everyone's read Genetic Algorithms document. How many times through have you guys read it? I'm going to start with a number, and then I'm going to increase it, and I want you guys to keep your hands up if you've read it for that many times. How many of you read it one time through? Okay, the entire class. How many of you have read it 2 times through? How many have you read it 3 times through? How many of you have read it 4 times through? Okay, and we lost everyone at 4 times. So 3 times is the max that we read it. I would say that for this document, it would be helpful to definitely read it at least 3 to 4 times through. There's a lot in it.
And that still doesn't really help with them.
Yes, that's still it's only going to get you so far. Obviously, the resources that are right here on the document themselves are saying the Wikipedia, which if you remember my review session from last week, I bashed the Wikipedia on how it was just too technical and didn't make sense at all. So that's fine. The tutorials point I'd say is decent. What it is good for is once you understand what a genetic algorithm is, it gives you a pretty good outline on what some pseudocode would be and how to structure it, and it gives you a diagram. During my office hours today, I was asked the question, how do you get started on genetic algorithm? And I wrote out on the whiteboard a few points on how you get started on genetic algorithm. The first big point is read the document you're given first. That seems like a no-brainer, but some people will skim it through and then go, I don't understand what this is asking. And I go, have you read this bullet point here in the paragraph? And they go, oh, it does say it right there. And I go, yeah, it's given to you. And so that's the first one, is read the document. The second one is make sure that you read any extra literature and watch any extra literature that you need. That is going to be super helpful. There's obviously many more resources than these 2 links in my review session on genetic algorithm. It's an actual thing. It's an actual CS thing. So you can find a lot of resources on all of this. And so read them until you understand it. What I also said that is a good recommendation is once you have all of these resources together, once you've read a lot of material and you start to understand what a genetic algorithm is, you should make notes. You should take notes on any paper documents you have or any digital documents and say, okay, I understand this thing here, I understand this thing here. And then also while you're doing this, make sure you read the code that Jesse gives you. That also seems like a no-brainer, but you want to read the code Jesse gives you before you start coding something yourself, because if you don't understand what his code does or what his code is saying, it's going to make it really difficult to code around with it. So once you have read these 3 things, you look at all of them and you go, okay, this makes sense. This makes sense. Okay, and then you might get to a certain thing and say, I don't understand this thing right here. And even after looking at a bunch of bits of literature and stuff, you still don't understand it. Let's say it's the incubator function. You look at it and you still don't get it. You can't figure it out. So you make a comment in your code, or you make a comment on a document that says, I don't understand this. Then what do? You go to office hours and you have a document that's written up to say, okay, I understand this, this, and this, and I don't understand this thing. Can you help me understand this thing? And that means that rather than you trying to troop on and code this thing without understanding a core part of its functionality, you can go to a TA and we can clear it up before you start going circles around trying to figure out what it is when you don't have any clue on what it is. And so making these annotations and bringing them to your TA and saying, I don't understand this part, is going to be super helpful. This entire process is a process you need to learn to love, because if you don't, it's going to make your coding way more difficult. Because if you don't spend time on doing these first 4 steps, what is going to happen is you are going to spend more time trying to code it than you should. Because if you try to just code it while not understanding anything that's going on, you're going to run more circles and you're going to code stuff you don't need to code, and you're going to freak out about an error that you didn't know that you didn't actually need to have, and that type of deal. And so by skipping the readings and skipping the annotations, it causes more work down the line. Now, the 5th thing that you need to do is, before you actually start coding, you've now read some documents, you now understand some documents, you've written notes on all the documents. Now what you do is you open up a Word document or a Google Docs, and you open it up blank. This is the key. No Control-C, no Control-V. You open up a blank document and you plan out your implementation in English or whatever your preferred language is on how you want to code this. And you actually write it out. Now, this isn't just copy and pasting tutorial points pseudocode. This is saying, well, if tutorial point says in a line of pseudocode, initialize your population, you actually write out on that paper how you want to initialize your population, what a population is. Basically, you rewrite Jesse's entire document, but in your understanding. Now, once you have that entire document done, you have a full implementation front to back on what you want to write. Now that you have a full implementation front to back on what you want to write, you can write it and you can start working on it. What this allows us to do is that also, if you have an error with your code and you go, my code isn't working and I don't know why, what we can first do is look at and see, hey, do you have a plan for your implementation? Now, if we look at your implementation and your implementation is just a misunderstanding and something's just wrong there, we don't even need to look at the code, because we can just go, hey, don't worry about what might be wrong or might not be wrong in the code right now. You actually implemented it wrong. You misunderstood a core part of the document, and we're going to actually say, no, this is wrong, do it this way. And based on implementation-wise, at that point then, you'll be put back on track, and it'll be up to you to then fix your implementation to follow what your implementation says to do. Now, if we look at your implementation when you say your code doesn't work and you don't know why, and we see that your implementation is correct on what you're understanding, then what we know is it's, okay, you just actually put English to code wrong. So then now we can look at your code and figure out, okay, you knew that you needed to do this here, but how you actually did it was incorrect. And so now we can look at your code and go, okay, well, you just need to change this syntax thing here, or change this syntax thing here. So that once you fix that, then because you had your implementation right, we just had to fix a small bug and then we were good to go. And that allows, one, for us to be able to answer questions more efficiently. It allows us to understand your code better, rather than also trying to look through possibly 150 to 200 lines of code spread out over a few different files, trying to figure out what were you trying to do and figure out. But if you give it to us in an actual paper, then we go, okay, well, this is what you were trying to do. Now we can look at it and say, was that right? And if it was right, then did you actually implement it in code the right way? And that helps us a lot, and it's going to help you a lot. Personally, for my own project, we have a 220 project right now that is, we have to create a custom memory allocator. We had no clue how this thing worked before this assignment. I'd say I've probably spent 15 to 20 hours on the homework assignment so far. The first 5 to 7 hours I spent was before I even touched the keyboard. That first 5 to 7 hours was reading documentation, reading on all the manuals that I needed to read, reading all of the resources that I could find, reading all of the provided materials, and then planning out my own implementation on how I wanted to do that. And that was the first 5 to 7 hours. That's a lot of time. But if I didn't do that, I'd probably run circles around myself and confuse myself and then bash my head against the keyboard and be really sad. So, once I had that done, I then started coding. Once I started coding, I coded my implementation, and that went pretty quickly. 3 hours, I'd say. It's a 5 to 7 hour implementation writing phase. It's going to at least be 2 to 3 hours of writing code. And so once I wrote my code, then I could debug it. Now, initially, actually in the first bit that I had written my code, because I had planned out my implementation fully, once I wrote my code and I submitted to AutoGrader, I actually was getting 60% of the points available to me on one go. That's because I spent all of that time planning it out and figuring out exactly what I needed to do. Eventually then what I decided was my implementation was fundamentally flawed and I wasn't going to be able to get the other 40% of points, and so I then had to go, okay, we need to change this around. And so then I replanned my implementation and fixed it around, and once I fixed it around, I then was able to improve stuff and get better at it. But it's that type of planning and processing phase that you need to get good at. That is a phase that you need to go through for all of your things. So when asked the question, how do I start genetic algorithm? The answer is that. You need to read the documents. You need to read the code that's given to you. You need to read and watch all the literature that you can get your hands on until you actually understand what the assignment is asking of you. Once you understand all of that, you want to take notes on all of that. And so you have notes and questions to ask the TAs if you need to ask the TAs questions, but you at least have notes to say, oh, this thing is this thing that I need to keep track of. This thing is important over here. And then once you have all that, then you can plan your implementation. Once you plan all your implementation, then you can put fingers to keyboard and start coding. Now, are any of you guys going to actually do this? Probably not. But I'm going to say it anyway because it's going to be helpful, and maybe eventually you're going to be with some coding assignment and you're going to look at the document and go, this looks really difficult, and eventually you're going to hear that little voice of me right in the back of your head, and it's going to be, hey, remember from genetic algorithm? You should read everything and plan it out before you code. And then you're going to think to yourself and you're going to listen to me, and I'm going to pop up on your shoulder, and you're going to have the devil on the right side of your shoulder, me on the left side, and it's going to be like me, plan your implementation. The devil's going to be like, nah, don't do it. And it's going to be like me, you really should.
Could you just describe one of your nightmares?
I mean, it could be described as a nightmare, but it'll be helpful. It'll eventually help you. And so one of those days, you're going to listen to me, and then you're going to try it and go, oh my God, that was so much easier to code my stuff. And once you learn once you learn your lesson, then you're going to continue doing that. And I'm going to be happy, even if I don't even if it's in a future class down the road. I'm not actually your TA, but I'll know. I'll feel a little warmth just around me, and I'll be like, someone definitely started actually following their implementation guidelines. Huh, that's great. I'm just going to have this epiphany. Let's see, in the middle of class, I'm just going to look up and be like, someone listened. It's going to be great, and I'll know. And so that's what I can say is, how you start this, you do that. Don't put hands to keyboard just yet. Especially don't put hands to keyboard if you don't understand what's going on. Because if I see that you've written code, and you've said, and then you also tell me, I also don't understand what's going on, I'm going to go, then why did you start writing code if you didn't understand what this function did? And then you're going to go, well, I thought I understood everything else. And I was like, but this is a core part of the assignment. Why did you start writing before you understood what this function is? And you're going to come up with some excuse. And I'm going to go, that's not fair. So here's the thing with genetic algorithm. You have essentially, it's a little bit formatted differently than other assignments. Specifically this assignment, the primary objective is the first thing you should do. Because for objectives 1, 2, and 3, yeah, you need it. That's why Jesse had the document formatted this way versus the other way around. All of these, objectives 1, 2, and 3, you create your own custom incubator and your own custom cost function, and then you just put it into genetic algorithm and let genetic algorithm do its work. So,
And hope to God.
and hope to God. I'm not necessarily one to fully believe in God, but it's one of those situations that once you code genetic algorithm and you write the objectives 1, 2, and 3, you pray. You pray it works. And if it doesn't, then that's a lot of testing ahead of time. And so what you want to do is you want to start with the primary objective. And essentially, once you write the primary objective, if it's working and you get those 20 points on AutoGrader, the last 3 parts of the homework shouldn't be too difficult, because the hardest part is writing genetic algorithm itself. This also means that if you don't get the primary objective,
You're probably fucked.
yeah, if you don't get the primary objective, I'd be really impressed if you were able to get objective 1, 2, and 3 points, because they directly call the primary objective. So code the primary objective first, start it early, because you want to make sure that you get it done early, so that at that point, if you don't understand it, you can bring it to TAs, and we can help you get it working and get it done, so that once it's done, then all you need to do is for objective 1, 2, and 3 is understand what a cost function is, what an incubator function is, and you need to write a custom one just for that objective so you can run some testing on it. That's it. Objectives 1, 2, and 3 are write some custom functions to feed into genetic algorithm, and genetic algorithm does the rest. And you just check that genetic algorithm, what it returns is what it should be. So if you had a polynomial function that evaluated with all its points, that what your function should return is a polynomial that is y equals x squared. So if you were to expand that, it's y equals 1 times x squared plus 0x plus 0. So you would have a list of doubles that would be eventually 1, 0, 0. Then you would check to see, hey, is the polynomial I get from genetic algorithm the same as the polynomial it should be? And that's your testing. It's not too far from being very intensive compared to genetic algorithm itself. So, I want to ask 2 questions before I continue talking, and which is, how many of you understand what an incubator function is in relation to this assignment? How many of you understand what a cost function is in relation to this assignment? Can anyone tell me what the parameter is for the incubator function? What is the parameter for the incubator function? A list of doubles. What does Jesse call a list of doubles in the document? Nope. Plural or singular?
Animal.
A list of doubles is 1 animal. Now, how long is that list of doubles is it going to be? Is it going to be a random number you decide? Is it going to be a predefined value? And if so, where are you getting that predefined value? The third parameter. Number of genes is, wait for it, the number of genes you're going to have for your list of doubles, aka the length of your list of doubles. So, you have to understand those 3 parameters. A lot of people have shown me code and shown me the document, and they show me the beginning of the primary objective and say, hey, Jesse gave us all of this. I didn't need to write that. Yeah, you didn't need to write it because he wanted to make sure that it was the right format. What you do need to understand is understand what those actually are. And if you don't understand what those actually are, ask questions, because you need to understand what an incubator function is, what a cost function is, and what the final number of genes are actually used for. So I'm going to talk about the incubator function first. The incubator function, as we just said, takes an animal, and what it returns is what? Nope. Incubator function. Huh? Type T. So the incubator function takes an animal and returns type T. So an animal is specifically what the computer understands. It's a list of doubles. Each double can have its range that you decide. Hint, my recommendation is do negative infinity to infinity as your range for doubles, because if you try to constrain your range of doubles to any range smaller than that, there is a possibility that the solution actually requires one more higher than your range or one more lower than your range. If your range was negative 200 to 200, what if the solution space required 201? If your range for your doubles was negative 200 to 200, you would never get there. You would always be one off. And so by constraining it to any number other than negative infinity and infinity, you are limiting your function. And what would happen is then you'd need to submit it to AutoGrader and figure out, oh, is my range too small? And then you'd need to manually adjust your range until you can make it bigger and bigger and bigger. And if you just spent that time trying to play around with your range, why don't you just make it negative infinity to infinity at the start? Is there any reason to? Okay. So if no one has a reason to why you wouldn't make it negative infinity to infinity.
My first thought would be because of runtime.
So.
Because it says specifically it's going to run 10 times.
Yeah, so the counterpoint is runtime. If you had the range as negative infinity to infinity, would runtime be the factor that you need to worry about? And the answer is, that's a good point. That would be one that you need to factor into if your genetic algorithm doesn't run quick enough. But if you think about it in the aspect of you are randomly generating numbers between negative infinity and infinity, and if you find one that is closer to your fit, what happens is you deal with the crossover and the mutation on it, and what you do is you keep moving towards that best fit that you have. Now, you may start out at having a range of negative infinity to infinity, but based on your crossover mutation, what happens is as soon as you find one point that's near what your solution actually should be, you start moving closer and closer and closer to it.
But then doesn't it randomly generate while you're moving closer and make sure that it didn't?
Yep. It sprinkles a few other points in there, but if one point is really far off, it immediately gets disregarded anyway. And so that one doesn't start moving towards the solution space that's near it, because you just go, okay, that one is just such a bad loss, I'm not even going to try chasing down and barking up that tree. And so that's where you need to tailor your crossover and your mutation to essentially calculate what your new population should be. And you should do that. That's where your runtime is really going to matter. Because if you don't approach the best fit solution close enough, then yes, that negative infinity to infinity range is going to cause some problems. So maybe then, if your crossover and your mutation function aren't getting near the best fit close enough, then maybe you want to lower the range down a little bit. But I'd say the bigger area you should be worried about runtime is being able to get closer and closer to the best fit during your creation of a new population. That's the key on where you need to decide how you're mathematically calculating a new population. How many animals you're going to do crossover on, how many animals you're going to mutate, and how many animals you're just going to pull from the old set and put in the new, and how many animals you're just going to randomly add in. And so, keeping all of those in mind, I would still recommend to have that range of negative infinity to infinity. What I would then say is to continue with the incubator function is because you're going from a list of doubles which each have their own range of infinity to negative infinity to infinity, it then converts it into the type t parameter. That type t parameter is whatever you're going to return. Coincidentally, what is also the parameter for the cost function? Type t. And so if you want to figure out the cost of a current animal that you have, you need to put it through the incubator, and then once you put it through the incubator, you can put it through the cost function to figure out how good of a fit it is. Now, for those of you who were here at the review session last week, what was the term I used to call the cost function? Started with an L. Loss. They're the same. They're synonymous. And so what it is that the cost function is the same as calculating the loss function. And so what it is you give it what you think your solution should be, and it outputs how good it fits with your data that you built your cost function with. So your cost function, as an example, would be, in the case of a polynomial, your cost function would have built in all of your data points that you are trying to fit to. What the cost function would also do is it would take a polynomial class that you would have custom constructed, and it would take a polynomial class and then say, for all of these points, figure out the total r squared with this polynomial class. And so if 0 is the best fit and 1 is the worst fit, it would output how good of a fit that polynomial you fed it fits with your data set. And so once you have that, you can say, okay, this polynomial fits really well. And so then you know that that polynomial is directly tied to a list of doubles, which is an animal, and you say, well, this animal fits really well, so that's an animal I'm going to keep for the next population, or I'm going to mutate it slightly for the next population. And it's keeping track of all of these and figuring out how you're going to keep track of all of their losses and figure out how you can minimize them and how you can mutate them and cross over them. To specifically read into this, the tutorials point gives some pretty good examples on that. That's where you need to keep track of everything. Awesome. Does everyone kind of understand what the incubator function is now doing and what the cost function is doing? Yeah, questions?
So, we are going to custom write
Yes.
the incubator function and the custom function. And the cost.
Not for the primary objective.
Oh, we don't write it.
The primary objective, they are given to you as parameters.
Yeah.
So you use exactly what is given to you as a parameter. You do not need to know what it does. For the reason being of when you have a genetic algorithm, it doesn't know what the cost function actually checks. It doesn't know what the loss function actually does, or that the incubator function. And so it doesn't know what a polynomial is. It doesn't know what anything is. It just knows that, oh, I'm given this cost function, and by putting my data set, an animal, through the incubator, I can then take what that's returned and put it through the cost function and say, this fits this well. And all the genetic algorithm does is it tries to minimize that value. It tries to get as close to 0 as it can. It has no clue what it's trying to get close to 0. It just knows that it has a way to evaluate how good of a fit it is, and it just tries to get it to the best fit it can. And so for the primary objective, you do not need to write a incubator function. You do not need to write a cost function. You just need to use it. Now, if you try to start writing a cost function and an incubator function in the primary objective itself, it is wrong. If you try to set up an animal in any other way than a list of doubles of length numbered genes, that's wrong. An animal needs to be that list of doubles that is the specific length of the number of genes that you are given as a parameter. If you do anything other than that, what happens is you would start hard-coding things. If we're trying to keep genetic algorithm generic, should you be hard-coding anything? For those of you who have done a decent amount of research, what is the one big thing you're going to hard-code in this genetic algorithm? Okay, well, I heard two answers, and I'll take two of the answers that are good. So one answer was the size of your population at any given time. That you're going to hard code. That's your choice on how big you want your population to be. The other answer I heard was your break point for the number of generations. Those are the two big ones. You choose specifically how your population is going to be built up and created. You will also choose how many generations your code will run. Now you can choose how it breaks. You can choose if it breaks after 200 generations, or you can choose if it breaks once the best solution gets within an error range. So you could say once the best solution has a cost of less than 0.01. I would say that the safest bet would be saying a number of generations that you predetermine is the max number of generations it runs for. The reason being is what you can then do is say, hey, if I get within this specific loss range, I just return the best fit. What the number of generations being capped at a certain number keeps you from doing is if the problem solution isn't able to be solved, you don't infinitely go on. You would need to set up your conditional a specific way if you wanted to have them both in the while loop conditional. That's your choice if you want to figure out how to set that up. If you say while this or that is true, then if you say while the loss is greater than 0.01 is true, if that loss never gets less than that, it will never break.
Even if you do or?
Especially if you do or.
Well, what if you get to like 200 generations?
If you say 200, if you say while generation is less than 200 or the loss is greater than 0.01, even if you get to the end where you say I'm now at 201 generations, what would happen is even if your loss is still greater than 0.01, it would keep running. And so if your loss never gets less than 0.01, that conditional never breaks. You can plot it out on paper to see. It's like, for those of you who have taken 191, you essentially just look at the conditionals and say, okay, when is this conditional going to break and when is this conditional going to break, and how do I set it up in a way that means that like the loss will break the conditional early and the number of generations will be the max amount of time it runs for. I'd say the easiest way to do that would be to have an if statement in your while loop that just says if the best fit is less than this loss, then return what the solution is, because that'll exit out of your while loop early.
If you do like return, it'll exit out.
Yes, because return will return the value and it'll be the end of the function.
Okay.
Make sense? And so basically the hard coding things that you are doing are creating the population in the way that you want to be creating and how you want to break this loop. This is laid out pretty well in pseudocode on the tutorials point. If I open it up right here, I will open it up. But if we then look at the introduction, I believe is where it is. Fundamentals, okay, there, I guess. I don't know. I've done this. I didn't look at the readings. I've already done the readings. So yeah, right here, that's a graph. That's a pretty good one to help you out with understanding what's going on. Here's also what a good one is. That right there, that's a genetic algorithm. Yours is going to be that with extra steps. Like, obviously, one line there, like initialize population, that won't necessarily be done in one line. But that's what's going to be there. Now you can choose to implement your genetic algorithm in exactly this way. That is your choice. This is material that we have given to you guys, and so you're allowed to implement it in that way. Now implementing it in that way is not working with your friend and having your friend code part of this, and then you coding the other part of it, and then swapping the parts that you didn't code, because you're based in the same implementation. Oh, I just could switch the code with your friend. That doesn't count. You can't do that. You still, even though you guys are using the same implementation idea that was given to you on tutorials points, you cannot copy each other's code. That's still no bueno. So don't do it. We'll catch you. You'll be sad because you'll get hit with AI. That's a very sad time. It's also a lot of paperwork, guys. You don't want to do that paperwork. So don't cheat. Please and thank you. So, what questions do you have for me about implementation questions about genetic algorithm?
I'm having trouble sorting.
Yeah, Sam first, and then.
No, you can go.
Okay.
I obviously know you want to sort by
That's a choice that you can do.
Okay, yeah, fair enough.
This implementation is super. What is that popping up? Oh, this advertisements. Am I dying, guys? Do I need hospice? And apparently PlayStation Now.
But if you want to store the values as the genes, you can't get it to like sort by the values of the cost function using the incubator values. Like, I don't know if that makes sense.
So what the question is, because I also want to reiterate it because we're recording so that anyone who's listening can also hear what the question is. The question is where someone is trying to sort their population by their cost for each animal, and they're trying to figure out how to do that. Now, the answer to that is there are custom sort functions that you can do in Scala that take conditionals or take functions. So what you need to do is essentially figure out a way that you can feed that sort function a function that takes an animal and what it returns is the cost. So that the sort function can sort by cost.
But I have to like write another function then?
Yes.
Oh.
You need to write a function or use the functions that you have and nest them into that sort function
Once I tried it, it won't work.
using the rocket icon. So specifically, the rocket icon, if in here is, the rocket icon, for those who don't know, is that. So if you are declaring a function inside of a Scala function, like as a parameter, that same icon that you use as a parameter in, let's say, anything for when you're passing a function, like in genetic algorithm itself, to, let's say that n is a list of doubles, and you want this function to return what its cost is. Specifically, you would just say n is that, and then you'd say rocket icon, and then you'd say cost function incubator of n, and what that right there would be a function that for n, where n is an iteration of whatever is being iterated, then it would just pass n through that function and it would sort by or just be seen as that. So there are a lot of functions in Scala that do a lot of things shorthand. If you're trying to look up a library and you're trying to figure out how to use a documentation, I know a bunch of the Scala shorthand stuff, so you can just see me in like office hours and I'll help with like the specifics on doing what you want to do. Yeah. So, other questions? Yeah.
I guess I have a runtime function. So you have the option of sorting it, like
Yeah.
sorting by the highest cost, right? Or lowest.
Lowest cost.
I'm assuming that would be faster than just searching for the lowest cost. I guess it depends on where the lowest cost is.
Think about it this way. If you want to search for the lowest cost, you would need to iterate through the function with a max being of n. Specifically, the representation would be O of I, or O of n, because the max amount of time that you could get is you might have to iterate all the way through to the end. Now, if you also want to use the second, the third, the fourth, and the fifth lowest cost, you would need to do that 4 more times. So you would need to sort that another 4n times. Now, that's going to start getting a little costly with every time you need to do that to build that. But if you sort something, specifically if Scala's built-in sort method is using merge sort, which has a runtime of n log n, then what happens is you sort once, and then you know that in order, the head of the list is the one with the lowest cost. Then you know that specifically the elements between 0 and 5, where 5 is exclusive, you know that you have 0, 1, 2, 3, 4, and those are the 5 highest elements, or the 5 lowest elements for cost. And so after sorting, you don't need to like keep this extra comparator and do this loop 5 times through the entire array to figure out, okay, well, this is the second best fit, and then this is the third best fit, and then populate this array. Instead, what you do is you just sort it once and you go, okay, I just pull all of this chunk of the array out. And those are the ones that I'm going to use that are the good fit ones. And then you're going to take those and you can do whatever crossover and mutation you want to do. And you can like carry over any of them that you want to do, and that's your choice. Yeah. Here's another big thing. This is a question for you guys. Should you introduce random animals with every generation? Yes or no?
Yes.
Yes. The answer is yes, because if we look over here, they had a good diagram, I think, on the first one. They had a good diagram right here. That what happens is if you choose one point to start at randomly, and you don't throw other random stuff in, what happens is right now they're saying that they're looking for the max. So if you threw that minimum point over here where there's the red line and the darker one that's at the lower point. So if you chose that point and that was your random point to start out with, and you just kept going until you found the local maxima, what would happen is you'd go till there. Is that actually the best, highest point on that entire graph?
No.
It's not. So you need to throw in more random animals every so often, because with every random animal you throw in, there's a chance that it's actually on one of these hills that go to the local minima or maxima that you're trying to achieve. Specifically for this assignment, you're trying to achieve local minima, because your loss is, you're trying to get a loss as close to 0 as possible. And so, like, if you had this guy right here, what you'd be doing is you'd be trying to find this point, but that's not actually the lowest point that you could find. It's over here, which is why you throw in random animals with every generation, because if you don't, what happens is you might end up finding a local minima rather than the overall minima of the graph. And so by throwing in random, you're decreasing the chances that you don't get to the actual best fit solution. Yeah, question.
So for the primary objective, we're just setting up like how it's supposed to run for everything.
Yes.
And then for everything else, it's just like exactly what needs to happen for each like situation. It's a polynomial or like.
So the genetic algorithm itself is generic, and what happens is for the primary objective, you set it up to use the parameters it has, and what it does is it runs and it tries to find the minima cost that it can, the global minima. Once it finds the global minima, or it times out after n generations that you have it set to, it returns the type T that you wanted that is of that current best fit. That is all the genetic algorithm is doing. What you are doing in objective 1 is once you have the primary objective done, you do not touch genetic algorithm as a function ever again. Once you have the points for it, what you do is in all objectives 1, 2, and 3 is you are writing custom cost functions and custom incubator functions, and you are feeding them into genetic algorithm. So you're just using genetic algorithm like you would any function call. But for objectives 1, 2, and 3, you should not be editing the insides of genetic algorithm. Once you code it, once you get the points for it, that means your genetic algorithm is working, and the rest of your points are going to get from testing it and actually like writing your incubator functions that you're going to feed in as a parameter, writing your cost functions, and just putting that stuff in. Make sense? So yeah, you're coding this in a little bit of a reverse fashion than you normally would. You're going to code the primary first, and then you're going to code the objectives 1, 2, and 3. Now, if you think you have the primary done, but you don't have the points for it, it means it's probably still broken, but now you're going to start writing objectives 1, 2, and 3 so you can debug your primary objective to figure out what's wrong with it. Make sense? If you come to me, and I'm going to hold to this. If you come to me and say, I'm not getting points on genetic algorithm for the primary objective, I don't know why, and I see that you haven't even tried writing objectives 1, 2, and 3, I am not answering your question. Because objectives 1, 2, and 3 are testing your primary objective. So autograder is not your tests. yeah, it's great if you submit your genetic algorithm and you're getting full points on it, because then you don't need to fret about anything, and you can just write the cost and functions and stuff that you need for objectives 1, 2, 3 and be done with it. But if it's not working, you need to write objective 1, 2, and 3 then, so you can then debug it and figure out, okay, is it getting to where it needs to be, and why isn't it going towards the lowest loss? Why isn't it getting to where it needs to be? And that's you debugging. But if you haven't written objective 1, 2, and 3, you haven't been trying to test your genetic algorithm, so I'm not going to answer your question why it doesn't work. Make sense? Everyone agree with that? That's fair? I see some reluctant nods. I think it's fair that if you don't try to test your code and you try to get me to test and debug your code for you, that's not my job. My job is to help you conceptually with material. My job is not to be your own personal debugger. Yeah, I'm kind of good at it. I've done it a lot, but that's not my job. I don't get paid to do that.
Can we pay you to do that?
No, that is called academic integrity. If you pay someone to do your work for you, that is academic integrity. I don't care if it's a TA or not. That's bribing a TA if you do that. I'm not accepting that, because that's also going to get me fired. You cannot bribe me. I will not be bribed. No, it doesn't matter if you ask me behind the scenes or in front of the scenes. I am not going to be bribed by you guys. I like my job. Okay. It's probably from my birthright stuff that it sees that I've been looking at travel visas to Israel. But yeah. Great job. Apparently, it also wants me to go to Brockport. I don't think it understands where I'm at right now, and why would I want to go to Brockport if I'm here?
Doesn't have location services.
Yeah. Okay. So, any other questions about genetic algorithm? Yeah.
A little off topic, but is genetic algorithm, is it considered like machine learning?
Yes. It follows similar concepts to machine learning, where it's the computer guessing, checking, and basing off of a loss function. I do not know if it directly falls under the machine learning category, but I would say yes, it's at least similar on how it works, which is why like the bonus objective is neural network.